To divide these two polynomials, we can use long division, but there's two things that we need to check first. First, we need to make sure that the dividend is written in standard form, which means its exponents go from highest to lowest, and we need to check to make sure that none of the powers on the variable p are missing, which they're not. And then we would check the same thing for the divisor. But since both of those conditions are met, we can just go ahead and put them into the division problem and get started. So the dividend goes inside of the division house, so 3p to the fourth plus 28p to the third plus 68p to the second plus 52p plus 26. All of that is being divided by p plus 6 on the outside. Now, to get the process started, you really don't need to concern yourself too much with the plus 6 right now. Focus in on just the first term here and just the first term here. And ask yourself, what do I need to multiply p by to make it become 3p to the fourth? Well, if you can think about it, p times a 3p to the third would equal 3p to the fourth. And so I put 3p to the third on top of the division house and I multiply around. 3p to the third times p makes 3p to the fourth. And now's where the 6 comes into play. 3p to the third times 6 makes plus 18p to the third. And after you multiply around, you're supposed to subtract, but when you subtract polynomials, you need to change the sign on all the terms. So this becomes a negative and this becomes a negative. And now you combine straight down. This should cancel because that's how we set it up. 3p to the fourth minus 3p to the fourth. In this case, 28p to the third minus 18 is going to leave me with 10p to the third. And then you bring down just your next term, so the plus 68p to the second. And now you start over. So you kind of ignore the 6 again for a minute, but now you're comparing just this p to just this first term. And you're asking yourself, what do I need to multiply p by to make it say 10p to the third? Well, if I multiplied p times 10p to the second, that would give me 10p to the third. So I put a positive 10p to the second on top, and I multiply that 10p to the second around. And again, I multiply it by p and by 6. So that gives me 10p to the second times p is 10p to the third. 10p to the second times 6 would be a positive 60p to the second. I need to change both signs so that I can subtract these. 10p to the third minus 10p to the third cancels out. 68p to the second minus 60p to the second leaves me with 8p to the second. Bring down your next term of plus 52p and keep going. And so now it's, what do I multiply p by to make it say 8p to the second? Well, I would have to multiply by a positive 8p in order to make it an 8p to the second. So now multiply around. 8p times p makes 8p to the second. 8p times 6 would make a positive 48p. Change both signs so that you can subtract. And in this case, 8p to the second minus 8p to the second cancels. 52 minus 48 gives us 4p. Bring down that last term of the plus 26 and do it one more time. So now, what do I multiply p by to make it say 4p? All I'd have to multiply that by there would be a positive 4. If I multiply the 4 around, 4 times p makes 4p. 4 times 6 would make a positive 24. Change both signs so I can subtract. And you'll notice this isn't ideal, but it happens pretty regularly when you're dividing. The 4p minus 4p cancels out, but 26 minus 24 leaves me with a remainder of 2. I would love it if it left us with no remainder, but that just doesn't always happen. So when you do have a remainder, here's what you do. You take that remainder, which in this case is a positive 2, and you add it as that remainder over whatever the divisor was. So in this case, it's 2 over p plus 6. And that's it. It's a long process, but that's why they call it long division. And so this would be the answer to the division of those two polynomials.